Hey guys, welcome back. So in this video, I'll be explaining a technique or a method that is known as difference array technique. Okay, and what difference array technique is, let's first understand that. And before understanding the method of difference array, let's first understand the problem statement. Let's suppose I have been given a problem where I have been given an array of size n. Okay, here as you can see, I have been given an array of size n, and initially all the elements of the given array were 0. Okay, and I have given a certain number of operations where I have been told to increment the index from 0 to 1 by 1, means the contribution between 0 to 1 is 1. So what I have to do is I have to increment 0 by 1 and 1 by 1. So basically what I have been given is a left index and the right index, and I have to increment all the values of the elements between this range left to right by 1, or you can say this can be any value, either 1, 2 or any value x. Okay, so for the sake of convenience, I'm taking the value of x equals to 1 here. Okay, so in the first operation we have to increment the values of 0 to 1 by 1. In the second operation we have to increment the value of 3 to 4 by 1. So I have incremented 3 to 4 by 1. Now I have to increment the values of the range 2 to 6 by 1, and here both the ranges are inclusive. Okay, so 2 to 6 I have to increment by 1. So this will become 2, and this will become 1, this will become 2, this will become 2, 1 and 1. And in the last operation we have to increment the range 4 to 6 by 1. So this will become 3, this will become 2 and 2. And in last we have to print this array. So this is a technique that has been used in many of the CP problems. I'll discuss one problem in the next video also. So what is the first approach that comes to your mind when you read this problem statement? Obviously a naive method is go through all the ranges and increment the values by 1, and our array will be ready. But what will be the time complexity of that particular method? Let's suppose we have been given the number of operations as 10 to the power 5, and the ranges that has been given are also between 10 to the power 5 range. So the complexity will become 10 to the power 5 cross 10 to the power 5. Okay, so this will be a very bad method to implement, as it will give TLE if you go for this method in the problem statement where you have to use this technique. So how we can optimize this? Let's talk about that. So here the concept of difference array comes in when we are trying to optimize the implementation of these operations. Okay, can we do this in order of n times and order of n time? So now I'm going to discuss the concept of difference array. I hope the problem statement is clear, and why we are implemented this technique, it is also clear. Now let's move on to the approach part. So in order to optimize these operations, we can either optimize the traversal, because this is taking order of n time, or we can optimize the traversal of these operations. Okay, these operations, the ranges, since we are traversing through all the ranges from L to R, we can optimize this because this is also taking order of n times. Okay, so these are the time complexities, vertical and horizontal. We can optimize any one of these, and since we all know that in order to process all the operations we have to traverse all the queries, or you can say all the operations, so we can't optimize this. So the only thing that we can optimize is this one. And now let's talk how we can optimize this. So let's suppose we have been given these number of operations, and I'm on the first operation. So we will make a new array of order of n size. In optimization of the n square, we are taking order of n space here, remember that. Okay, and when we are processing the queries, now let's suppose I'm on the first query where we have to increment the values of 0 to 1 range by 1. So I'll just increment the value of 0 by 1. I'll increment this value by 1, I'll increment this index by 1, and I'll decrement the value of r plus 1, basically 2, by minus 1. And why I'm doing so? When let's suppose I'm taking the prefix sum, I'll take the prefix sum, what will happen? This will jump to this, because previous will be added to the next one. Okay, and this will be jumped to next one, and this will become 0 here, and for the further indices it will move as 0. I hope you got a glance that why we are incrementing the left as 1 and right plus 1 by minus 1, because by taking the prefix sum we will just nullify the effect of this after the last index that was useful for us, this one. Okay, after this index it will become 0. So I hope it is clear that why we are doing this. And now let's do this for all the particular queries. So first operation is 0 to 1, so I'll increment 0 by 1 and 2 by -1. Next operation is 3 to 4. Let's remove this one. So next operation is 3 to 1, 3 to 4, sorry. Okay, so I'll just increment 3 by 1 and 5 by -1. And since these numbers are not as per 0 based indexing, so we have to take the new array as size 0, order of n plus 1, because it is not as 0 based indexing, so it will might go runtime error. Okay, so next query is 2 to 6, so I have to increment 2 by 1, this will become 0, and 6 by, not 6 but 6 plus 1, 7 by -1. Okay, next query is 4 to 6. What I have to do, just tell I have to increment 4 by 1 and 7 by 6 plus 1, 7. I hope it is clear. 7 by -1, so this will become -2. After performing all the operations, I have to just simply take the prefix sum of this array, and that prefix sum will give me the contribution of all the particular index. Okay, let's do the prefix sum and see what we are getting here. Let me erase this and write here. So here prefix sum will go as 1, 1 plus 1, 1, 1 plus 0. It will initially be 0. All elements will be initially as 0. This will be 1, 2, 2 plus 1, 3, 3 minus 1, 2, 2, and it will here become 0. So now this prefix sum will tell me what are the contribution of each point that has been given in the operations. And if we go naively, let's print it naively. 0 to 1, we have to increment 0 by 1 and 1 by 1. Fine. We have to increment 3 and 4. 3 to 4 range by 1. 3 and 4 I have incremented. 2 to 6, 2 by will be incremented by 1. 3 will be incremented by 1. 2, 4 will be incremented by 1. It will become 2, 5 and 6. Fine. Now 4 and 6. 4 to 6 I have to increment by 1. So this will become 3. This will become 2 and this will become 2. As you can see that this array and this array is similar. Okay, 1 1 2 3 2 2, 1 1 1 2 3 2 2, and this will be the 7th index that is not of any use for us. So this is the concept of difference array that you can use in any problem where these kind of operations is given, and we have to find the contribution of each point in the range given. Fine. So here I have taken the value of x as 1. For example, x is 4, then you can just simply increment this by 4 and decrement r plus 1 by -4. So this will give the contribution of 4 at each particular point. Okay, so this is the concept of difference array that has been used in any many problems in the CP, and it will make our complexity very efficient and our life easier. Okay, complexity will be order of 2n, because first for traversing all the queries and order of n for taking the prefix sum. Okay, so the total complexity of this technique will become order of 2 cross n, where n is the size of the array that has been given to us. So I hope the concept of difference array is clear to everyone. If there is any doubt remaining, you can ask in the comment section. I'll try to answer your queries. Okay, thank you for watching this video.